Hi everyone. By the end of this video, you will have a clear idea on combination of errors or uncertainties. Combination means how do we calculate the error in addition, subtraction, and the next one is calculating error in multiplications and divisions. Let's see how to find combination of errors. Let's see the first rule. Rule for combination of errors in case of addition and subtraction. Suppose you made two measurements. Let me say you made a measurement of A. Look at this. A is measured with the real value and its absolute error. B you measured as real value plus or minus its absolute error. And you are doing addition of those two measurements. Then this shows the maximum possible error in your result. Just add both the absolute errors. Let's see a question. We measured the length of the rods with a ruler. Rod number 1 has a length this much. This is the true value and this is the absolute error in measuring length of the first ruler. This is the true value of the ruler and this is the absolute error in measuring length of the second rod. They wanted the total length of the two rods placed end to end, which means they just wanted to calculate A plus B. Let's see the given things. True value of A, error in A, true value of B, and the absolute error in B. The first question they wanted total length, which is A plus B. You add this with this, will give you 30.0. This is the length of the two rods together. Now what do they want? The second part of the question, they wanted the absolute error in total length, which is this. Error in A, absolute error in B, which gives you 0.3 centimeter. What is the third one they wanted? They wanted the percentage error in total length. To get the percentage error in total length, we have to find relative error first. Relative error is absolute error divided by the total value. Absolute error in total length is 0.3 and the total length is 30. And to get this is a relative error. To get the percentage error, you times it by 100. The answer is 1%. Now, we go for the rule for subtraction. Same thing, whether you add your measurements or subtract your measurement, the error in the result is just add them. Why we add them? Because we are looking for the maximum possible absolute error. Maximum possible absolute error means you just add the two absolute errors. Let's do a question. Someone made a measurement of mass of an empty beaker. This is the true value and this is the absolute error in measuring the mass of A. Then some liquid in that and the new mass becomes the true value and the absolute error in the measurement of the mass with the liquid. They wanted the mass of liquid added. How do you get the mass of the liquid added? You go for the difference between the two. Let's see the given things. Mass of empty beaker, mass of beaker with liquid, error in the first measurement and the absolute error in the second measurement. They wanted the difference in masses, which is bigger number minus smaller number. Bigger number is 75.68, take away 25.68. The result will give you 50 grams. So this is the mass of liquid added. Second part of the question, they wanted absolute error. The maximum absolute error will be just add the individual absolute errors. What are the individual absolute errors? 0.01 in the first measurement and 0.01 in the second measurement. You add them together. This gives you the absolute error in total mass of the liquid. Now for the third part, to get the percentage error, you find relative error in your result times 100. How will you get the relative error? Absolute error in your result, which is 0.02 divided by the total mass of the liquid, which is 50. And to get the percentage times 100, which will give you 0.04%. The third rule, we go for rule for multiplication. In case of multiplication, we add fractional errors, not the absolute errors. Look at the rule. Fractional error in your result equals fractional error in your first measurement plus the fractional error in the second measurement. And once you get it, times 100 will give you the percentage error. Same rule applicable for division. Let's do a question on multiplication. The question says a farmer measures the length of the field as like this. The true value is 100 and the absolute error in length is 0.5. And he measured the width as 50 meter and the absolute error in width is 0.5 meter. He wants the area of the field. For area, we have to go for multiplication, length times width. Length is given as 100, width is given as 50. When you multiply them together, the area will be 5000 meter cube. Now the second part of the question, they wanted relative error in length and width separately. Relative error is the ratio like this. So we go for the relative error in length. 0.5 divided by 100 is 0.005, no unit. They wanted relative error in width. Absolute error in width, which is 0.5, and width is 50. Plugging the numbers, which will give you 0.01. Relative error in width. Now, the third one is relative error in area. How do we find the relative error in area? You add relative error in individual measurements. The relative error in length is 0.05. Relative error in width is 0.01. You add them together will give you 0.015. Relative error in area. Now, how do you get the percentage error? Times this by 100, which is 1.5 percentage. Another question. Table has a length of 120 centimeter. Table has a width of 50 plus or minus 0.5 centimeter. They wanted area of the table. For that, the given things. Length is given. Error in length is given. Width is given. And the error in width is also given. Area, just simple math. Multiply length by width. How much is the length? 120. How much is the width? 50. Which gives you 6000 centimeters square. We are looking for the relative error in length and relative error in width. Just take the ratio, which gives you 0.005 for relative error in length, and the relative error in width will be 0.5 divided by 50, which gives you 0.01. They wanted the total error in area, relative error in area. The rule says you add the individual relative errors. The first relative error in length is 0.005 plus relative error in width is 0.01. You add them together, which gives you 0.015. And how do you find the percentage error? Times 100, which will give you 1.5 percentage. There is one more part for the question. Last part of the question, fourth one, they wanted absolute error in area. And we have to express the result in the form of this. Relative error in area is 0.015. And what do they want next? They wanted absolute error in area, which is this number, del A. How do you get del A? To get del A, move A to the other side. Then it becomes times A. How much is the area? Which is 6000 centimeters square times 0.015. 90 centimeters square. So this is the absolute error in calculating area. How do we express the final result in this format? The calculated area is 6000 and the absolute error in area is 90. So 6000 plus or minus 90 centimeter cube. We move on to division, the maximum possible error in the result. Add the individual relative errors. And to get the percentage, times it by 100. Let's do a question. The question says while measuring speed of a car, we have to measure the distance. How much is the distance measured? 100 meter. And how much is the error in distance? 0.2. Time taken to travel that distance, 5 seconds. And the error in measuring time is 0.05. What do they want? They wanted speed of the car. Just we divide. Speed equals distance divided by time. How much is the distance? 100. And how much is the time? 5, which will give you 20 meters per second. That is the speed of the car. It's not over. Now they wanted relative error in distance and relative error in time. To get the relative error in distance, absolute error in distance divided by true value of distance. 0.2 divided by 100, which gives you 0.002. Relative error in time, absolute error in time measurement divided by time, which is 0.05 divided by 5, which gives you 0.01. Next, they wanted relative error and percentage error in calculation of the speed. The rule says the fractional error in calculating speed is fractional error in distance plus fractional error in time. How much is the fractional error in distance? 0.02. And how much is the fractional error in measuring time? 0.01. You add them together, will give you the total fractional error in measuring speed. And how do you get the percentage? Times 100, which will give you 1.2 percentage. Now the last part, they wanted absolute error in speed. Why? To express the result in a proper error format. We know relative error in speed is 0.01. What do they want? They wanted del V. For that, 0.012 times V. How much is V? 20, which will give you 0.24 meter per second. So this is the absolute error in calculating speed. And how do you express the final result? The calculated speed 20 and plus or minus 0.24. Another question, similar one. The question says they wanted to calculate the time period. They gave you the formula for calculating the time period, and they gave you length measurement is given in such a way and the time measurement is given in such a way. So length is 20 centimeter, error in length 0.1 centimeter, time measurement 90 centimeter, error in time is 0.9. They wanted percentage error in calculating G. So first thing, we have to rearrange this equation in terms of G. This is given. When you square on both sides, it becomes t square. 2 pi square becomes 4 pi square. Root disappears. It becomes L divided by G. Make G the subject. To make G the subject, swap the position between G and t square. It gives you G equals 4 pi square remains there. L also remains there. T square goes to the denominator. First part over. 4 pi has no error. Why 4 pi has no error? Because we are not measuring 4, we are not measuring pi. It's a constant. For constants, there will not be any error. Now you can see this is kind of division and t square, which is kind of multiplication. So the fractional error in G can be written as like this. No error in 4 pi square, fractional error in L. Divided by t square. T square is t times t. Multiplication, you have to add del t divided by t plus another del t divided by t. So rule says if it is t square, it will be 2 times. If it is t cube, it will be 3 times delta t divided by t. Since it is t square, we just go for 2 times the fractional error in time. Plug the numbers. How much is del L? Del L is 0.1. L is 20, and 2 times del t is 0.9 and t is 90. When you do the calculations, that will give you 0.005 plus 2 times this gives you 0.01. When you add them together, the final value is 0.025. This is fractional error in measuring G. Are they looking for fractional error? No, they are looking for the percentage error. How do you get the percentage error? Times 100. That's it. 2.5 percentage. Let's do some MCQs. The mathematical operations in which the accuracy is limited to the least accurate. Least accurate means more error possible. Is it addition, subtraction, multiplication, or both A and B? To do that, I'll give an example. Suppose you are adding. Remember, the rule says while you add, you have to follow least number of decimal places. 2 decimal places here, 1 decimal place is here, 3 decimal places here. So the final result should have least number of decimal places, 1. This is rounded off to 1 decimal place. So you threw away so much of information, which means more error is possible in addition or subtraction, less accurate. Now let's cross-check for multiplication. In case of multiplication, we follow least number of significant figures. Here you have 2 significant figures. Here you have 3 significant figures. And when you do the calculation, it gives you 3 significant figures. But we keep only 2 figures, 8.6. Just 1 figure is rounded off. Here, how many of them we threw away? 2 decimal places we threw away. Here we are throwing only 1 decimal place. So less error possible. Less error possible means more accurate. They wanted least accurate. So it is not multiplication or division. It is addition and subtraction. So the answer is D. They are doing division. The maximum possible percentage error. Just add the fractional errors, which gives you the total fractional error in calculating y, since they wanted percentage times 100. So the answer is B. Thank you so much.